Concept 3, elimination using multiplication first. So sometimes, in fact a lot of the time, we will not have a system where we have a variable that shares the same or opposite values for its coefficient, right? I've got 1y and 3y and 3x and 4x. Okay? So I can't just eliminate one of these by adding or subtracting. So the first thing I have to do is multiply one of these equations so that I do have the same or an opposite value. Okay? Generally, when you do that, you want to multiply the equation that has the lowest term, the lowest value of a coefficient, especially if you've got 1, right? So I've got 1y here. That means I'm going to want to multiply this equation by 3 so that these two are equal. All right. If I try and get my x values equal, it's going to get messy. They're kind of like fractions, like fraction denominators. I'd have to multiply this whole equation by 4, and then this whole equation by 3, and get 12x and 12x. Or use some fractions, multiply this whole thing by 4/3. But regardless, it's going to be messier than just doing my multiplication by 3. Okay, so let's start there. I know I want to eliminate my y variable, so I'm going to multiply this by 3, multiply this by 3, multiply this by 3. So, and I'm going to skip down right below. I'm going to have 3y equals 9x plus 15. Okay. And then I am going to, because my terms are the same, subtract. Right? I've got my terms all lined up. Now I'm going to subtract. 3y minus 3y is going to be 0. Okay, and you can write this a number of different ways for the subtraction. If you want to write it like this, or you can change each of your terms to a negative sign. Whatever you're more comfortable with, that's fine. Just make sure that whichever method you use, you are keeping them straight. Okay, a lot of the times where you go wrong is when you subtract this term, but then you add this term, or you forget the negative sign on a term. So it's not the worst idea to write them all out as well. In fact, let's do that for this one, just so we can see how it will look. Okay, so I would have 3y minus 3y. That's that. I would have 4x minus 9x. And negative 10 minus positive 15. Okay, and now I can combine my terms. 3y minus 3y, 0 is equal to 4x minus 9x, negative 5x, negative 10 minus 15, negative 25. Okay, let's go ahead and move our x value plus 5x plus 5x, and rewrite that over here. I've got 5x equals a negative 25. Okay, quick divide by 5, x is equal to negative 5. All right, now I can plug that back into either one of these equations, or, and this is generally the easiest, you plug that back into your original equation. Okay, and remember my original equation was just y is equal to 3 times negative 5, that's my x, plus 5. Okay, and the reason why it's easiest to go back to that original one, the one you multiplied, is because since that started at 1, it's already isolated for me. Okay, 3 times negative 5 is negative 15 plus 5. So y is going to equal negative 10. And that's my point. I've got negative 5, negative Okay. It is very important with these to show your work. I think I've said that already for systems of equations, but with this many steps and having more than one equation, it's very easy to make little mistakes that give you the wrong answer at the end. Okay. All right. So here's another one. My terms aren't quite lined up, so it's not as nice, but they are on the right side of the equation. I've got both my y's, both my x's, and then on the other side I've got my constants. Okay. So actually the first thing I'm going to do is line up my terms vertically. Okay. The step 1, step 2, they can take place in different orders, and sometimes it helps to line them up vertically beforehand if you're going to be multiplying. So let's do that. I don't have to change anything. I don't have to add or subtract anything. I just have to change my order. So I've still got x minus 2y equals 3. All right. And then I'm going to move my negative 4x, remember to bring the term with it, plus y equals 2. Okay. Now that they're lined up, it's a little easier for me to make my decision on which one I want to change. Okay. And in this one, I've actually got a coefficient of 1 for both my x and my y in one of the equations. Okay, so I can choose. Doesn't really matter. You'll end up with the same answer anyway. But generally, if I am choosing, I am going to try and make them or use the least amount of steps that I have to. Okay, so if I've got a smaller term, then I'm going to use that one. So instead of having to multiply by 4 or negative 4, I'm going to multiply by 2 or negative 2. Okay. I'm going to use addition. So I want these to be opposite. So I'm just going to multiply by 2, multiply by 2, and multiply by 2. Okay. And that'll give me negative 8x plus 2y equals 4. And just to help, I'm going to bring these down. X minus 2y equals 3. Okay. Because I'm using addition, I am not going to rewrite it like I did with the ones above where my terms are together. I'm just going to do it vertically. So x plus a negative 8x is going to be a negative 7x. Negative 2y plus 2y is going to be 0. So I'm just going to leave that off. That's my eliminated term. And then 3 plus 4 is 7. This is kind of a weird looking 7. Okay, so I've got negative 7x equals 7. Or, and I'm going to skip the step and just say, hopefully we can all see that x is going to be equal to negative 1. All right. Now I'm going to go back up, and again I want to go to that equation that has the y isolated, right? Or the one where you have y with a coefficient of 1. Okay, so I've got y minus 4 times negative 1, so minus 4x equals 2. Negative 4 times negative 1 is y plus 4 equals 2. Subtract 4, isolate my variable. Y is equal to negative 2. So the answer to this would be negative 1, negative 2.